Hello, P-Calculus students. This is Mr. McAllen, and this video today is to talk about tricky limits that we may encounter on the AP test. Now, we all know the strategy for evaluating limits, and typically when we see a limit as h or as the limit value goes to 0, we would try plugging that in, and if we got 0 over 0, don't fall into the trap and think that the limit is non-existent. Make sure you exhaust all options. For example, on this first problem, what they're getting at is this is the definition of the derivative from the beginning of the year where you had a function evaluated at 2 points, and it's basically the difference quotient. So where it simplifies into just being f of x plus h minus f of x all over h, and we're limiting h to go to 0. So this is their crafty way to see if we can recognize the definition of the derivative in limit form. So what you have to do for this one is you simply figure out what the function is. Well, in this case, f of x is e to the x, and you have to figure out where you're taking the derivative at. And x is at the location 2. So the derivative of this function is e to the x. The function value at 2, the derivative value at 2 is e to the 2. So the derivative of this function would be choice D. If, let's say, they gave you a function that looked like the limit as h goes to 0 of the sine of pi plus h minus the sine of pi all over h. This also would be a definition of the derivative, but this time the function would be sine of x, and the derivative of sine would be cosine of x, and they'd be asking you simply to find the derivative at pi with this definition of the derivative, which in this case would be -1 when you plug pi in. Moving on to the next type of limit, this is where they give you a polynomial over a polynomial. Now in this case, a lot of students, they want to just look at the ratio of coefficients, but that test only works when x goes to infinity or to -infinity. In this case, we first try to plug in 0, and what we end up getting is 0 over 0. But don't put non-existent. You first have to try to factor or exhaust all possibilities of algebra in terms of simplifying. So if you factor out the greatest common factor, which is x cubed, on the numerator is actually 2x cubed, and you have x to the third plus 3 over, and you're going to factor out in the denominator x to the third, and what's going to be left is going to be 4x squared plus 3. I just want to make sure I factored that out correctly. So the only common factor here was an x cubed. So now the x cubes cancel, and I can reevaluate my limit. Let me just clean up the problem a little bit. And that is as x goes to 0. And we end up finding out that we have a limit of 2 over 1, because inside the parentheses here will be 3 over 3. So my choice would be choice D. Next one is where we actually do have a polynomial where x goes to infinity. And in this case, because the polynomials are all FOILed out, there's no tricks here. We look simply at the highest power, the leading term in the numerator, and the leading term in the denominator, and we can just look at the ratio of coefficients. In this case, it's 1/4. That's a relatively easy one. But there have been other problems where they say x goes to infinity, and they say x minus 3, x plus 5 all over 3 plus x, x plus 7. And what kids will do on this one is they'll just look at the leading term, and they'll say that it's just going to be 1. But you have to make sure that in this case you FOIL out the numerator and denominator completely. X squared plus 2x minus 15 all over, in this case in the bottom, it's going to be, let me just erase that so we're not confused. It's going to be x squared from these two. It's going to be plus 10x and then plus, I think, 21. And in this case, you look at the leading term and you're going to actually have, in this case, leading term is coefficient is 1 over 1. But you must make sure that before you do that, end case scenario, you foiled out the polynomials and you make sure you definitely have the right leading terms. So that's another example of some tricky limits. Here we just have a graph where they ask us to find the limit. So a lot of times kids don't understand that, pardon me, I guess that's allergies. We have the limit as x goes to a from both sides. So to make sure that a limit exists, if they ask you what's the limit as x goes to a, you really have to check what is a function doing from both sides. So you have to look at what the function is doing as x goes to a from the left. Does that equal the limit as x goes to a from the right? And in this case, the limit does both go to the same value. From the left, it goes to 2, and from the right, it also goes to 2. So in this case, the limit would exist. It would have a value of 2. And if they did ask you something along the lines of continuity, you would have to say it's not continuous. Even though the limit exists, we have a big hole in the function at x equals a. So hopefully that helps you with that type of a question. That's all I have for tricky limits for this video right now, but look at the rest of the videos in this playlist, and it will help you with certain types of questions on concepts where they throw some really interesting tricks at kids on the AP test. Hopefully this helps, and I look forward to hearing your comments.